This is Mission Control Houston. We want to welcome you to today's Space Station Live. It is Wednesday, October 30th, 2013. This is a live view inside the Space Station Flight Control Room here at the Johnson Space Center in Houston, Texas. Today, the team is being led by Flight Director Emily Nelson. Sitting beside her at the Flight Director console is David St. Jacques. He is today's Capcom. He'll be the one speaking with the crew up on board the space station itself. It's a pretty busy day for the crew. Expedition 37 in progress aboard the orbiting complex. Today, Fyodor Yurchikhin, who is the commander of Expedition 37, is busy working to pack up some items and equipment that will come back home with him. Luca Parmitano, one of his fellow crew members, as well as Karen Nyberg, will also be flying with him aboard the Soyuz spacecraft as they get ready to come home on November the 10th. Oleg Kotov and Sergei Ryazanskiy also working today in the Russian segment to set up and resize the Russian Orlan spacesuits that they will use on November the 9th as they step outside for a spacewalk with the Olympic torch, which is soon to be arriving at the space station with the brand new crew that's going to be heading up there. But they're going to be taking that out on the 9th for a spacewalk on the Russian segment of the space station with that Olympic torch in hand. Also today, Parmitano and Yurchikhin will test out some systems on that Soyuz we were talking about in advance of the spacecraft's relocation from Rassvet to Zvezda. That's going to be taking place on Friday morning. They will undock at 3:34 a.m. Central Time and redock their spacecraft with the Zvezda service module, which is on the back end of the station, at 3:58 a.m. Central Time. This will make way for the arrival of Rick Mastracchio, Mikhail Turin, and Koichi Wakata coming up in November. Of course, we'll have live coverage of all of that here on NASA television on Friday. Mike Hopkins, another Expedition 37 crew member, has a monthly fitness evaluation today using the stationary bicycle on board the station. Later today, he will participate again in the ultrasound, the spinal ultrasound experiment. This uses ultrasound technology to take measurements of the crew member's spine. The goal of the experiment is to help determine and better predict changes that happen to the spine on orbit. Crews have seen up to a 3% increase in height while in space. They get a little bit taller, which sometimes causes back pain and other symptoms. So the spinal ultrasound will take a look at better ways to predict how that could affect certain crew members and whether there is certain commonalities in between the crew members that can better predict how they're going to react to it. Hopkins also working with what's known as the SLAM-D device today. This stands for Space Linear Acceleration Mass Measurement Device. This is located in the Columbus Laboratory. You see it sort of sticking out there with a blue tip on the end of it. What it does is take a look at Newton's second law of motion by having two springs generate a known force against the crew members mounted on an extension arm. You see that arm there. The resulting acceleration being used to calculate the subject's mass. This device is accurate to 0.5 pounds over a range from 90 pounds up to 240 pounds. So it basically takes care of everybody. This is basically how they weigh themselves in space because obviously they can't really step on a scale up there. Karen Nyberg is retrieving some samples today in the Melfi. This is the minus 80-degree laboratory freezer on board the ISS. It's a big freezer that is extremely cold. This is a cold storage unit that maintains experiment samples at ultra-cold temperatures throughout a mission. So she's going to be taking one sample from one to another and getting those ready to be packed up and come back home. We've got some busy times ahead for us here on NASA television and for the crew of Expedition 37 and soon to be 38 on board the space station. We're doing things a little bit out of order this time. Typically, we land a crew and then launch a crew, but this time we're going to be launching one before we land another. So here's a look at our programming schedule on NASA television. Beginning on Wednesday, November 6th at 9:15 p.m. Central Time, we'll have launch coverage as Rick Mastracchio, Mikhail Turin, and Koichi Wakata get ready to head up into space. At 10:14 p.m., that is when the launch will actually take place. On Thursday, November 7th, beginning at 3:45 a.m. Central Time, we'll have docking coverage here on NASA TV. And then at 4:31, that is when that docking is due to take place. At 6:15 a.m. Central Time, that's when we'll have hatch opening coverage. And then at 6:40, that's when the actual hatch opening will take place. And for once in several years, we'll have 9 crew members on board the space station and 3 Soyuzes actually docked with the orbiting complex. And then for our landing coverage, as Fyodor Yurchikhin, Luca Parmitano, and Karen Nyberg get ready to come home on November the 10th, At 1:30 p.m. Central Time, we'll have the farewell and hatch closure coverage here on NASA TV, with the actual hatches being closed at about 2 p.m. Central Time. Undocking coverage will begin at 5 p.m. Central Time, with the actual undocking taking place at 5:26. And then our landing coverage will begin at 7:30 p.m. Central Time. The deorbit burn that will bring this crew home will occur at 7:56 p.m. Central Time, with the Soyuz landing actually taking place at 8:50. And then we'll have a video file early Monday morning at 9:30 a.m. Central Time here on NASA TV, with a wrap-up of all the day's activities.
Proceed.
This is a live view of the space station. It is high to the east of Canada right now, about 260 miles above the Earth, just over the Atlantic Ocean, about to make a pass over parts of Europe, and then Eastern Europe, and then over parts of Asia, and then end up over the Indian Ocean in just a few minutes.
Yeah, we have PO, folks, if that's what you mean. I'll check. Luca, that actually means magnetoreological, but i.e. it reacts to magnetic fields, but you can skip that line if you want for fluency. Hey, Luca, so this is good input. So you know what we'll do? We'll move on to message 2 while we let PO come up with a more elegant solution. It's just further down in the same document on page 5.
As the space station continues to fly above the Atlantic Ocean, the crew on board is working on quite a number of different activities throughout the entire complex. Right now, Fyodor Yurchikhin and Oleg Kotov are performing a test of the video system that will be used in the Russian segment during all this Soyuz traffic that's coming up. Again, there's going to be a launch that will take place first with Rick Mastracchio and Koichi Wakata and Mikhail Tyurin. They will head up to the space station on November the 6th. They will dock in the early morning hours of November the 7th. And that video system will be used as they near the Rassvet module of the International Space Station. Now, Rassvet right now is occupied by the Soyuz that brought up Yurchikhin, Parmitano, and Nyberg. That's why they have to move over and make way for the new Soyuz. But that Zvezda service module was vacated earlier this week by the European Automated Transfer Vehicle cargo craft. It backed away. That vehicle's due to deorbit on November the 2nd in the early morning hours. But that port is now open, so they're going to be moving their Soyuz over there for just a few days until they get ready to come home. But they are already busy packing their Soyuz full of the items that will come back home. There's quite a bit of equipment that they need to bring back home. And they've already done the leak check on the Sokol launch and entry suits. Those are the suits that they wear for launch and landing. So everything is proceeding according to plan. Now all they have to do is just undergo what's called departure preps. Basically, that is just packing their luggage that will come back home. So there's some items, personal items that they need to bring back home. One item of note that is coming back is this piece of Luca Parmitano's spacesuit that was removed and replaced late last week. It's known as the fan pump separator. And what that is a piece of equipment in there that helps circulate air and water inside the suit. It also removes water vapor from the air that the crew uses and helps keep the suit cool with the water that has been circulating. But the suspicion is that this may have been the part that caused the leak in Luca Parmitano's spacesuit back in July. They did do a test. Mike Hopkins was doing that last Friday on the spacesuit, and once he got the new part in there, he fired that suit back up and did not notice any more water inside, which of course is good news. But that part is going to come back home aboard the Soyuz. It will board the NASA plane that will be awaiting the crew. It'll come back to Houston. They will do some forensic examination of that piece of the spacesuit, and then they should be able to say that that is the root cause and finally declare victory on this challenge that we've had with Luca Parmitano's spacesuit. So that'll come back home aboard the Soyuz, as well as the crew itself, obviously, and then the crew's supplies and equipment are being packed up this week as they get ready to return to Earth. This is Mission Control Houston. Let's go down now to the Marshall Space Flight Center in Huntsville, Alabama, and talk with Lori Meggs. Lori, typically we wouldn't be talking about a printer heading up to the space station, but we hear that this one may be a little bit different and special.
That's right, Josh. It's not your average printer. This is a 3D printer that could be used on space station where NASA astronauts might not have to wait on resupply spacecraft to get their supplies. They may be actually able to build something right there. Joining me now is Nikki Werkheiser, and she is the 3D print project manager here at Marshall. Nikki, first of all, tell us what 3D printing is all about.
Hi, Lori. Happy to. Thank you for having me. 3D printing, a 3D printer will extrude plastic, metals, or other materials to build layer on top of layer to create a three-dimensional object. So you might be able to print all sorts of tools, spare parts, things like that.
So it kind of sounds like the Star Trek replicator, right?
Absolutely. We get that a lot, and it is the first step toward that.
Tell us how it all works.
Okay, the 3D printer that we're going to fly in Space Station will actually be the first ever 3D printer in space. There are tons of printers many people have heard about on the ground. As a matter of fact, my 9 and 11-year-old daughters are asking for one for Christmas. And they have them at Staples and places like that, and you can create all kinds of things with them. But the one that we're looking at for microgravity, of course, we want to build space parts. So the design optimization is very important. As we all know, in space, you have to wait for, as you mentioned, the resupply ships if you need a spare part, or you have to fly a lot of spares up, which take considerable mass and which cost money. Also, things break, and things do actually get lost. We've been on space station for quite a while, and things get sucked into corners and crevices.
No.
Yes, it happens. And on top of that, there are unique type of things that we could do if we had a capability to build in space. For example, CubeSats. Many people have heard about these small CubeSats, and with the onset of nanosat technologies that we have, these are used for all sorts of things in academia, commercial, and you actually can deploy them from the space station. If we were able to print these on orbit, the crew could assemble them and deploy them from station. You can do all sorts of unique structures and just an abundance of different types of experiments.
So this one was built here at Marshall?
Yeah, this one was printed here, and this is just kind of the case of one. It's got some electronics that go inside, and you deploy from station.
So how long does it take to build something like that?
Something like this would actually only probably take an hour, hour and a half. And then you also have things like this. It looks pretty non-assuming. It looks pretty simple. You could print this probably in 15 to 20 minutes. We would just upload a CAD drawing to the printer on station. But what this is actually is MSG, an extraction tool that they did not have on orbit. And actually MSG was down for around 6 months waiting on a resupply ship to bring this up. This is something with the 3D printer capability that we could have actually printed, had on orbit within 30, 45 minutes, able to go.
Wow, what else do we see here? That
we've got some other just fun things. Of course, people think of crew tools and wrenches. We've got a metal one here too, and we're starting with plastics for this first printer, but we will be moving to metals and other types of materials. We've got things like, you can imagine, different size sample containers. You can also do interactive.
Oh,
sorry about that. That wouldn't happen in space. It would float away. So you have interactive parts like this that can move. You can do complex parts as well with unique structures.
So tell us about the unit that is actually going to station.
So we're working with the company Made in Space. They're actually located at Ames Research Center, and the project is led here out of Marshall Space Flight Center. It's a really good interaction between this commercial company, whose business model is to create a commercial additive manufacturing 3D printing facility on space station. This is the first step. It is a technology demonstration. We'll operate inside the Microgravity Science glove box. And NASA has been providing the discipline expertise and the expertise in terms of taking a printer that you would use on the ground, which Made in Space are absolute experts on that, as well as designing for space, and making sure that we can verify that for microgravity, the physics of microgravity, as well as the safety and operational constraints in the controlled environment of space station.
And this is also critical, being able to replace parts like this on orbit for future long duration.
Absolutely. The big thing about this is for space station even, it will decrease risk, decrease cost, and increase efficiency. But for longer term missions, for space exploration, this is absolutely a critical technology.
And talk about the ones that we have here on Earth. Will this technology make them better?
Absolutely. There's a lot of applications. We talked to several of our industry partners as well as academia, even international partners on the ground here. This is an area that has exploded in the last few years. It's been being used in an abundance. So the lessons learned from the microgravity application could actually apply to things on the Earth, especially when you think of things such as maybe the Army. Maybe you have folks out in the field in a remote area, and they have the same type of problems we have in space. Things break and you're remote. You can also think of things like submarines or even just remote regions. Also commercial growth. So in this smaller size and form and function that you get from the printer, you could absolutely apply that to Earth applications.
So we've seen the video of the printer and work with that, but how big is this unit? I mean,
so this is kind of cool. I don't know if you can see it here, but this is actually, we printed a model of the 3D printer. This first printer will be a technology demonstration, so it's a little smaller because we fit it inside of the Microgravity Science glove box on Space Station. So the crew will actually put their hands inside of the glove box to operate the experiment. We're getting a lot of materials data, and ultimately what this will demonstrate is that the objects that we print in space are equitable quality to those that we print on the ground, that there are no difference in the way that the printing takes place in the physics and the material quality. Made in Space has already done a series of parabolic flights on the KC-135, affectionately known as the Vomit Comet, and they've had excellent results. Everything has shown that it is equitable to Earth, but you get the short spurts of microgravity, and we want to be able to generate full products on orbit.
I'm sure astronauts are excited about this, so tell me when we'll see this on station.
And we will see this next fall and be launching on SpaceX 5, and we're actually working with the astronaut office now. We already have a set of tools and things that they've picked out and said, hey, can you provide this for us? And we're working toward that now.
Very exciting stuff. Can't wait to see it. I'm maybe building something a little bit later on today.
Absolutely. We're having a lot of fun with this.
Thank you,
Lori.
Nikki, so much. And let's take a live look into the Payload Operations Integration Center. Busy at work today, setting up some experiments. SLAM-D, they're working with the crew on station today to get that working, and they'll be busy all day long and all week long. That'll do it for us here in the Payload Operations Integration Center. Now back to you, Josh, at Mission Control in Houston.
All right, thank you, Lori. That 3D printer could change the way we do business here on board the International Space Station, make it quite a bit easier for the crews on board the space station and us here on the ground to get supplies to them. So we thank you for that. Back now with a live look inside the Space Station Flight Control Room here in Mission Control, Houston. The team also busy here. This is the Orbit 2 team. As we mentioned at the top of the broadcast, Emily Nelson is today's flight director. Sitting beside her is David Saint-Jacques with the Canadian Space Agency. He is today's Capcom. Astronaut Chris Cassidy just walked into the room. He, of course, just now getting back onto Earth, sort of getting his Earth legs underneath him, getting used to being back on the planet after almost 6 months up in space. He's been doing a series of meetings with the training team and everybody else that prepared him for his flight over the last couple of weeks, just talking about his experience on board the space station and also how those lessons learned could be applied to future crews. This is Mission Control Houston. Every time the crew heads up to the space station, they oftentimes take up some personal items just to keep them occupied during their downtime on board the space station. Of course, they don't have that much downtime, but when they do, they sometimes spend some time looking out at the Earth below, taking pictures. Or in Karen Nyberg's case, she has actually been building a quilt in space. This is one of the first times that this has ever been done. She is a lifelong lover of arts and crafts, and she took up some sewing supplies.
Now that I've tried my hand at sewing in space, I can say one thing with certainty: it's tricky. First of all, it's keeping all of your things in order. Ziploc bags come in very handy. I have to keep all of my extra fabric and thread and scissors and all of the supplies that I'm using in a bag when I'm not using it, so they don't just float away. So the bags come in extremely handy. When I'm actually doing the sewing and you want to have things readily available, I have this sheet of pile Velcro, and I can clip it to Velcro on the wall, and I can keep a pair of scissors, Velcro, my magnetic case with my needles, my spool of thread, and then also a straight edge. Which brings me to the next point that makes sewing in space very tricky, is cutting the pieces out straight. Getting the correct seam allowance. You can't lay things down and measure and cut. The fabric doesn't. I found myself taping the fabric to a surface, trying to get it to lay it out. I actually started using. I measured a 3x3 square on a piece of cardboard, and I would actually trace this onto my fabric and cut what seemed like it was probably a 1/4 inch seam allowance around that, and then of course when I start piecing the pieces together, it becomes very tricky when the pieces do not have the 1/4 inch seam allowance that you really had hoped for, and it's less than perfect. I think I would have chose a fabric that doesn't fray, perhaps maybe a felt or something like that. Now in hindsight, I wish I had brought something like that to sew with, where you could cut. The seam allowances don't matter, you just cut the design you want and then maybe do some top stitching on it to make something. So my experiment here of sewing and hand sewing, and I don't hand sew all that much on Earth. I usually use a sewing machine, and so there's also that patience of hand sewing, and I respect those who do that a lot. But in keeping the things together, that in itself can make this a little more challenging. And then of course, like I said, cutting the pieces out, getting the edges straight, and then keeping it together. I don't have pins with me here, and so I've tried a few different things. I've tried using some tape and taping the edges, and I have 5 needles, and I can use those as pins when the ones I'm not using, and try and keep the pieces together. But also that can be tricky, and it's taken me a long time. I'm almost done with one single 9x9 quilt block that has taken me quite a while, a lot longer than you would expect it to take. But it's been fun. It's been a fun experiment, and it'll be neat to have a quilt block that I can say was actually sewn during my time in space. This is what I've made. It's far from being a masterpiece. I've discovered several challenges with cutting and piecing and stitching in weightlessness, but it was made in space. I'll be bringing this block back with me when I return to Earth, and I'm inviting all of you to create your own star-themed quilt blocks. We'll be combining them with my block to create a quilt for next year's 40th Anniversary International Quilt Festival in Houston, where I hope to make a special appearance. If you're interested in participating in this fun project, all of the important details are available at this year's festival. I can't wait to see what we make together.
Message Luca on to you.
Si, senor. Yes, Luca. Go ahead.
Hey, David, I'm not sure that this is for a call for you or for Huntsville, but I'm ready to start with the SAM's screen clean, and I wanted to go for that.
Yes, sir. You are go.
This is Mission Control Houston. We want to take a look at our upcoming programming in support of all the different launch and landing activities that are coming up over this next several weeks, which will be busy for us at 9:15 p.m. Central Time on November 6th. That is when we'll have launch coverage here on NASA TV. The actual launch will take place at 10:14 p.m. Central Time. And then Thursday morning at 3:45 a.m. Central, that is when our docking coverage will begin, with the actual docking taking place at 4:31 a.m. Central Time. Hatch opening coverage as the crews get ready to greet one another will begin at 6:15 a.m. Central, with the actual hatch opening at 6:40. And then at 8 a.m., that is when we'll have a video file with all the different highlights from the evening's activities if you missed any of it. And then as we take a look at what's ahead for the actual landing of Karen Nyberg, Luca Parmitano, and Fyodor Yurchikhin, all that will take place on Sunday, November 10th. At 1:30 p.m. Central, that is when we'll have farewell and hatch closure coverage here on NASA TV. The actual hatch closure will be at 2 p.m. Central. Undocking coverage will begin at 5 p.m. with the actual undocking at 5:26. Landing coverage will begin at 7:30 p.m. Central with a deorbit burn that will bring the crew back into the Earth's atmosphere at 7:56. And the actual landing itself will take place at 8:50. And we'll also have a video file the next morning at 9:30 a.m. Central Time for all the different activities and highlights of that previous evening's landing.
Go ahead, Mike.
Yeah, Mike, you asked for a serial number on the UCK?
Sure did, yeah, thanks.
It is HRF 14104 Juliet in Col 1, overhead 4, Delta 2. And that's line item 1 in the stow notes. And also I have a location for the empty to be placed in Col 1, overhead 3, Bravo 2.
And that's the urine collection too, right?
This is Mission Control Houston. One of the things that astronaut Karen Nyberg has been doing during her time on board the space station, in addition to all the different incredibly busy science activities she's been working on, is she took up some sewing supplies. She's always been a lifelong lover of the arts and the crafts, and one of the goals that she had was to make a piece of a quilt while she has been up on board the space station. That piece will be brought back to Earth, and what she's doing is inviting people around the world to make pieces of this quilt to join hers. The International Quilt Festival actually began this week here in Houston, and at next year's activities, that is when some of her materials and this quilt will be on display. But here's Karen Nyberg on board the space station talking about her process and some of her supplies as she takes part of this quilting activity up on board the space station.
Now that I've tried my hand at sewing in space, I can say one thing with certainty: it's tricky. First of all, is keeping all of your things in order. Ziploc bags come in very handy. I have to keep all of my extra fabric and thread and scissors and all of the supplies that I'm using in a bag when I'm not using it, so they don't just float away. So the bags come in extremely handy. When I'm actually doing the sewing and you want to have things readily available, I have this sheet of pile Velcro, and I can clip it to Velcro on the wall, and I can keep a pair of scissors, Velcro, my magnetic case with my needles, my spool of thread, and then also a straight edge, which brings me to the next point that makes sewing in space very tricky, is cutting the pieces out straight, getting the correct seam allowance. You can't lay things down and measure and cut. The fabric doesn't. I found myself taping the fabric to a surface, trying to get it to lay it out. I actually started using. I measured a 3x3 square on a piece of cardboard, and I would actually trace this onto my fabric and cut what seemed like it was probably a 1/4 inch seam allowance. around that. And then of course when I start piecing the pieces together, it becomes very tricky when the pieces do not have the 1/4 inch seam allowance that you really had hoped for, and it's less than perfect. I think I would have chose a fabric that doesn't fray, perhaps maybe a felt or something like that. Now in hindsight, I wish I had brought something like that to sew with, where you could cut the seam allowances, don't matter, you just cut the design you want, and then maybe do some top stitching on it to make something. So my experiment here of sewing and hand sewing, and I don't hand sew all that much on earth, I usually use a sewing machine, and so there's also that patience of hand sewing, and I respect those who do that a lot. But in keeping the things together, that in itself can make this a little more challenging. And then of course, like I said, cutting the pieces out, getting the edges straight, and then keeping it together. I don't have pins with me here, and so I've tried a few different things. I've tried using some tape and taping the edges, and I have 5 needles, and I can use those as pins when the ones I'm not using, and try and keep the pieces together. But also that can be tricky, and it's taken me a long time. I'm almost done with one single 9x9 quilt block that has taken me quite a while, a lot longer than you would expect it to take. But it's been fun. It's been a fun experiment, and it'll be neat to have a block, quilt block that I can say was actually sewn during my time in space.
This is what I've made. It's far from being a masterpiece. I've discovered several challenges with cutting and piecing and stitching in weightlessness, but it was made in space. I'll be bringing this block back with me when I return to Earth, and I'm inviting all of you to create your own star-themed quilt blocks. We'll be combining them with my block to create a quilt for next year's 40th Anniversary International Quilt Festival in Houston, where I hope to make a special appearance. If you're interested in participating in this fun project, all of the important details are available at this year's festival. I can't wait to see what we make together.
So once again, this is Karen Nyberg on board the space station talking about her quilting activities as she gets ready to bring that piece of the quilt back to Earth aboard the Soyuz that she and Luca Parmitano and Fyodor Yurchikhin will ride home. Currently, she's busy inside what's known as the crew quarters. This is basically the little mini apartments, if you can call it that, aboard the space station that the crew members sleep in. They have to take care of these, as you can imagine. Since it is their living space, they do some periodic cleaning to make sure that there's no bacteria growing in there. They clean out all the different dust and other items like that. So she's been working on that for the last several minutes, and will continue. That's one of the station's vacuum sweepers you see there. She's also been busy today retrieving some samples from the Melfi. This is the minus 80-degree laboratory freezer on board the space station. It's got different drawers inside of it that keep the different experiment samples at all kinds of different temperatures, most of them extremely cold. But she's been moving some samples from one drawer into another one that's colder as they get ready to bring those samples back to Earth. She and Parmitano and Yurchikhin will be busy on Friday as well as they relocate their Soyuz from the Rassvet module over to the Zvezda service module. It's a quick little trip. It should begin at 3:34 a.m. Central Time and be concluded about 20 or 30 minutes later at about 3:58, but we'll have live coverage of that relocation at 3 a.m. Central Time, 4 a.m. Eastern Time here on NASA TV. Again, they're doing this to make way for the Rassvet port to be opened up for the arrival of Turin, Mastracchio, and Wakata aboard their Soyuz. But this will be the first time that we've had 9 crew members on board and 3 Soyuzes located outside the Russian segment in quite some time. But since this crew is going to be coming home in the next several weeks, they're the ones that are going to scoot over and make way for Mastracchio, Turin, and Wakata's Soyuz, since it'll be based on Rosvet the entire time that they're up there on board the space station. But here's a look at that crew. These 3 astronauts and cosmonaut are busy down at the Baikonur Cosmodrome. They headed down over the weekend. They're undergoing some final training and other preparations as they get ready to launch into space coming up on November 6th. We are getting ready to wrap up Space Station Live for today, but we want to remind you that coming up next on NASA Television will be today's video file. That'll begin at 11 a.m. Central Time, noon Eastern Time here on NASA TV. We will return tomorrow at 10 a.m. Central Time, 11 a.m. Eastern Time here on NASA TV for more Space Station Live. But for all the latest, you can always log on to the NASA website. Just go to www.nasa.gov/station to take a look at what all the crew is up to and all the different science that they're working on a day-to-day basis. We will see you back here tomorrow. This is Mission Control Houston.